Assalamualaikum and hi everyone. We are from MEMS 11. My name is Shafika. My matrix number is 181031745. The materials that used in RF MEMS sensor are magnesium alloy for the heaters, copper alloy for the submembrane, and the structural steel for the substrate. The dimensions of heaters are 0.0 mm thick, 0.1 mm thick of the membrane, and the substrate is 2 mm thick by using space clamp ANSYS. On the mechanical ANSYS, voltage is 100 volts, so the temperature can reach 517.18 Kelvin and 1.245 times 10 power of 8 watt per meter square is the total heat flux. However, when voltage is changed to 0.1 volt, the temperature is only 300.01 K while the total heat flux is 4995.1 W per m square. So the higher the voltage, the higher the temperature and the total heat flux and vice versa. Since the sensor has maximum temperature around 2 heaters, the sensor will reach thermal equilibrium state. As conclusion, the smaller size of heaters has high sensitivity and can reach temperature up to 600 K. Thus, temperature of heaters are changed when the dimensions and voltage are different. That's all from me. Thank you.
Assalamualaikum, my name is Nur Ain Atira. I will present the result from the simulation of RF MEMS power sensor. The material used for the design are gallium arsenide as a substrate, gold as a MEMS membrane and tantalum nitride as the heater. The input for the simulation is a power with a value of 200 mW while the output are temperature and electric voltage. Figure 1 shows the distribution of the temperature field under 200 mW input power level and the result for power versus temperature. Figure 2 shows the DC output voltage under 200 mW input power level and the result for power and versus voltage. As can be observed from the result in Figure 1, the temperature is mainly distributed around the two symmetrical terminal RF fitting resistor. The highest temperature around the resistor is approximately 344.45 Kelvin respectively. As the size of terminal resistor increase, the temperature produced by the RF filter gradually decrease for the given power. The experimental finding in Figure 2 show that the performance of this design has excellent RF DC linearity with a power of 200 mW. Furthermore, as the dimension of the terminal resistor exactly increase, the corresponding output response and sensitivity are gradually decreased.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Anis Najwa binti Raja Karudin, matric number 1810317.1. I'm from MEMS 11. I have been designed the electromagnetic thermal electric of indirectly heated RF MEMS power sensor using ANSYS 2020 R2 Academic Teaching Introductory. From this slide, we can see the result, the dimension, the input, the output, and the materials. In this model, there is have 6 parts, which is geometry, material, coordinate system, connection, mesh, and input-output. For geometry, there is have 3 types such as substrates, MEMS membrane, and heater. For materials, there is have 3 types, which is copper alloy for substrate, aluminum alloy for MEMS membrane, and structure steel for heater. Next, for input and output, the input has 3 types such as temperature, heat flow, and voltage, while the output has 2 types, total heat flux and temperature. First figure is about the thermal electric of total heat flux. The minimum is 116.81 watt occur on substrate, and the maximum is 1.3278 times 10 power of 7 watt occurs on MEMS membrane. While next figure is thermal electric of temperature. The minimum is 50 Celsius occurs on heater and the maximum is 1613.8 Celsius occurs on MEMS membrane. This slide is about MEMS thermal sensor in fight against COVID-19. In the fight against COVID-19, various technologies gain traction, each one driven by specific application or need. One example of application is the early detection of possible COVID-19 symptoms, among which is a fever. The purpose is to isolate febrile people for safety reasons and then provide future diagnostic testing to verify if they have the virus or not. For that reason, the thermal sensor is most important in the fight against COVID-19. It allows for fast, contactless screening of body temperature in various non-medical environments. Application of the technology RF MEMS focus on thermal sensors for basic temperature sensing detection or temperature imaging by microbolometers and thermopiles. That's all from us from MEMS 11 Thermal Sensor. A very thank you so much to Sir Muhammad Hafiz bin Ismail. Thank you.